All right, let's go to number 6. So this is a generic salt, AB2, has a molar mass of 317 grams per mole and a solubility of 4.00 grams per liter at 25 degrees Celsius. What is the KSP of the salt? So I believe we're question 6. Just give me a second here. Yeah, so that's 1, 2, 3, 4, 5. Yeah, we're question 6 here. So AB2. So what I want to do is I want to first figure out, again, the chemical reaction for this one, for the salts here. Right? So I have AB2. So what this is going to break down, so again, this is a salt, so I know it's an ionic compound. So I have some type of cation and an anion. It's going to break down into, I'm going to write our equilibrium sign as well. It's going to break down into, again, I have A 2 plus and B 1 minus, right? And then the reason why we know this is because of this coefficient of 2, right? You can think of the reverse crisscross, and you can think of the 2 here used to be the charge of A, and the 1 here used to be the charge of B. So A would have to be 2 plus charge, and B would have to be a minus charge here. And in order for us to balance this equation, I would have to put a 2 here for B here to get to balance out the B's. So again, now I can write the KSP formula for this salt here. So if KSP is going to equal to, again, just the, I'm looking at the concentration of our products, right? So I'm going to have A2 plus, and then I have, again, B minus here, but we have to include this coefficient, so this is going to be B minus squared here. And because the coefficient of 2 is in the exponent of our concentration in this case here. So what do we have? We have a molar mass of 317 and a solubility of 4.0 grams. So what we want to figure out is we want to figure out the KSP, right? So we want to find out first the concentration of these guys here. So how do we figure out concentration? Well, we have our molar mass here, which is grams per mole. And then we have the solubility, which is 4.00, which is grams per liter, right? And we have grams per liter. And we want to get moles per liter in, because that's going to represent our concentration, right? So we have grams per mole and grams per liter. So I'm going to have to divide both of these guys here, right? So grams per mole multiplied by liters per gram. And let's see. That actually might not work out because I get liters per mole, which is actually not correct here. So I would have to do grams per liter first, divided by grams per mole. So I have grams per liters times moles per gram, and this would cancel out to get moles per liter. So this is our equation here. So grams per liter, which is our solubility, and then divided by our molar mass here, which is grams per mole. So let's do this calculation. And again, the reason why I did this is because we're not specifically given a formula for solubility and for molar mass, so we had to actually use this concept of dimensional analysis for us to figure out which units would cancel out to give us moles per liter, and that's why I did this little side work here. So grams per liter, which is 4.00 grams per liter, and we divide that by 317 grams per mole. And this will give us moles per liter, right? Because again, these grams will cancel out and the moles will actually come up here. So we have 4 divided by 317 is going to be equal to 0.0126. And then we have moles per liter here, so our concentration. And then what we can do now is we can actually sub this concentration into our KSP formula. So let me just rewrite that for us here. And 0.10126 is going to be our x values here. So we can say that this is 0.0126 multiplied by 0.0126 squared, which is simply just, we have 0 point, I'm missing a 2 here for our formula here, because again we had the coefficient of a 2 on this side here, so that has to be reflected on our in our KSP formula. So you can think of it as 2s minus here. So I'm going to have a 2 as well. So this is going to be multiplied by 2. That looks really bad. Give me a second. So I'm going to have 2 times 0.0126 squared. And then this is going to give us our final answer, right? So we can plug this all into our calculator. Let's see, we have 0. I'm going to do 2 times 0.0126. I'm going to square that, and I'm going to multiply again by 0.0126, and it'll give us a value of 8.00 times 10 to the negative 6. This is going to be a KSP value, and as you can see, this is very, very close to this KSP value. So it will give us the correct answer for this problem. So so 8.00 times 10 to the negative 6. So this is the correct answer. And I think they're slightly off. I think they did the math slightly off, or maybe they actually kept more decimals, which is actually probably better in this case. So let me keep a little bit more decimals and see if that changes our answer in terms of rounding. And it would. So they actually they kept more decimal places here, so they actually got 8.4 times 10 to the negative 6. So let me just change this then here to reflect those decimals. So I thought taking 4 decimal places was enough, but I guess it was not. So that was my fault. There we go. So that's what you should plug into your calculator, and then you get a value instead of 8.04 times 10 to the negative 6. And this will be our KSP value for this problem. So this solution is correct. They actually did a better job than I did, because I didn't take enough decimal places for the concentration.